गुड आफ्टरनून ऑल ऑफ यू। हमने जो है पिछले लेक्चर में फेवर्स की रिएक्शन डिस्कस किया था, ठीक है। आज जो है हम उसी से सेम रिएक्शन देखें, कॉफी फेवर्स की रिएक्शन। ओके, इट इज ऑल्सो कॉल्ड एज बेंजेलिक एसिड मॉलिक्यूलर रीअरेंजमेंट रिएक्शन। ओके, so what is the difference in between Quasi reaction, Quasi Favorski reaction and Favorski reaction? Okay, the main difference is only the substrate molecule is used in the Quasi Favorski reaction. Now look here, in Favorski reaction the substrate molecule is alpha haloketone. Okay, this is the cyclic ketone, and at alpha position of cyclic ketone one halogen group is present. Okay, so it is called as alpha haloketone. Okay, and on another hand this carbon is called as alpha carbon, and at which at least one acidic proton is present. Okay, so this is the substrate molecule of Favors normal Favorski reaction. Okay, but in case of Quasi Favorski reaction the difference is only at the alpha position no proton is present. Okay, suppose here present two alkyl group. Okay, here no proton is present, means alpha proton or acidic proton is does not present in the reactant of Quasi Favorski reaction. Okay, it is also called as alpha haloketone because of at alpha position one halogen group is present, but another end there is no alpha proton is present. Okay, so this is the main difference in between Favorski reaction एंड कॉसी फेवर्स की रिएक्शन। सिंपल कॉसी फेवर्स रिएक्शन में जो अल्फा पोजीशन है हेलोजन के अपोजिट साइड में, वहाँ पर एक भी एसिडिक प्रोटॉन प्रेजेंट नहीं है। देखो यहाँ पर एक भी एसिडिक प्रोटॉन प्रेजेंट नहीं है। ये कार्बन जो है ये कार्बन से अटैच है और ये कार्बन से अटैच है, ठीक है। और यहाँ पर दो अल्किल ग्रुप प्रेजेंट है, ठीक है। एक भी अल्फा प्रोटॉन प्रेजेंट नहीं है, नो अल्फा प्रोटॉन इज प्रेजेंट। लेकिन फेवर्स की रिएक्शन में जो है अल्फा पोजीशन पे एटलीस्ट वन एसिडिक प्रोटॉन मस्ट बी प्रेजेंट, होना ज़रूरी है। अगर नहीं रहा तो फेवर्स की रिएक्शन शो नहीं करेगा। तो ऐसा सबस्ट्रेट मॉलिक्यूल जिसमें अल्फा प्रोटॉन प्रेजेंट नहीं है लेकिन वो है अल्फा हेलोकेटोन, उस वही सबस्ट्रेट मॉलिक्यूल जो है कॉसी फेवर्स की रिएक्शन क्या करेगा, शो करेगा। ओके, तो ये हो गया उसका सबस्ट्रेट मॉलिक्यूल और उसका डिफरेंस। फेवर्स की रिएक्शन और कॉसी फेवर्स की रिएक्शन में क्या डिफरेंस है, सिर्फ एक डिफरेंस है, अल्फा पोजीशन पे एसिडिक प्रोटॉन जो है प्रेजेंट नहीं रहता। ओके, और फेवर्स की रिएक्शन में एसिडिक प्रोटॉन और अल्फा प्रोटॉन प्रेजेंट रहता, ठीक। ओके, नाउ लिसन केयरफुली हाउ टू डिफाइन कॉसी फेवर्स की रिएक्शन। द कॉसी फेवर्स की रिएक्शन is defined as in which at alpha position of alpha haloketone no proton is present, then the conversion of alpha haloketone into ester in the presence of alkoxide are called as Cauchy-Favorski reaction. The reaction in which at alpha position of alpha haloketone no proton is present, then the conversion of alpha haloketone into ester in the presence of alkoxide, in which change in carbon skeleton called as Cauchy-Favorski reaction. In short, conversion of alpha haloketone into ester in presence of alkoxide in which no proton is present. Okay, the reactant does not have any alpha proton. Okay, it means it shows Cauchy-Favorski reaction. Okay, Now look here. Here I am taken the alpha haloketone like that. Okay. Now look here, at alpha position one chlorine is present mean it is alpha haloketone. On another hand, this carbon does not have any proton. No having H proton. Okay. It does not have any acidic proton or no alpha proton. Okay. So this molecule easily shows Quasi-Favorski reaction. Okay. So in the first step of reaction mechanism, simply the alpha oxide a reagent is act as a nucleophile. Okay. And it attacks on the carbon atom of the alpha haloketone. Okay. So due to this pi bond shifted toward the oxygen and oxygen here a negative charge, or we will get this type of intermediate polar. Okay, we will get this type of intermediate product. Okay, by the attack of nucleophile OR into carbon of carbonyl compound. Okay, after the formation of this type of intermediate product, we want to neutralize this negative charge of oxygen. Okay, we want to neutralize this negative charge of oxygen. So this negative charge of oxygen further migrate in between oxygen and this carbon atom. Okay, due to which here pi bond will be generated, and simultaneously this bond shifted toward the carbon atom. Okay, due to the shifting of this bond towards carbon, this carbon become negative species. Okay, negative charge species. Then these negative charge species of carbon is attacked on SN2 type into this carbon atom. Simultaneously here Cl will be removed and we will get this type of product. Now look here, firstly I am writing this carbon atom. Okay, then here pi bond will be generated between oxygen and carbon. Okay, this carbon also have a OR functional group. Okay, and this carbon is bonded with this carbon atom. Means here CH2 will be present. Okay, and this negative charge carbon is like attack on this carbon atom like SN2 type. So this carbon is bonded with this CH2. Okay, this carbon have the alkyl group, and here Cl will be removed. Okay, so we will get this type of final product called as ester. Okay, this product is formed from the alkoxide. It means here reagent alkoxide is used, so we will get a ester product. Okay, so this is the simple reaction and their mechanism of Quasi-Favorski reaction. The main difference in between Quasi-Favorski reaction and normal Favorski reaction is the substrate molecule does not have any alpha proton. Okay, and in the Quasi-Favorski reaction, the reagent is act as a nucleophile instead of base. Okay, and it attack on the first step on carbon atom of the carbonyl compound to form this type of intermediate. And after the formation of this type of intermediate, we want to neutralize this negative charge of oxygen. So simply this negative charge is shifted in between carbon and oxygen. So here pi bond will be generated, due to which this bond shifted toward the carbon atom. This carbon contain negative charge, and this negative charge carbon is attacked like SN2 type on this carbon atom. Simultaneously here Cl will be removed and we will get our final product ester. Okay, I hope you will be understand better. This is all about the Quasi-Favorski reaction. Okay, for better understanding I will give another example. Now look here, here I write this type of substrate molecule. Okay, now look here, this is our carbonyl functional group. Okay, on another hand, at alpha position, this Cl is present, so it is called as a alpha haloketone because of alpha position of carbonyl compound containing halogen group. Okay, on another hand, now look here, pH is present. Okay, and this carbon atom does not have any acidic proton or any alpha proton. Okay, so don't be confused. This substrate molecule shows Quasi-Favorski reaction, not a Favorski reaction. Okay, so what will happen here? Look here. Firstly, we will take here hydroxyl reagent. Okay, so this hydroxyl reagent firstly attach on this carbonyl compound, carbon atom of the carbonyl compound. Okay, due to which this pi bond shifted toward the oxygen, and we will get this type of intermediate product. Okay, we will get this type of intermediate product. Okay, after the formation of this type of intermediate product, we want to neutralize negative charge of oxygen. So this negative charge is shifted, migrate in between oxygen and carbon. So here pi bond will be developed. So due to which this bond is shifted toward this carbon atom. Okay, so this carbon become a negative species. Okay, and this negative species, sorry, this bond is shifted toward this carbon atom. Okay, this negative charge is migrated in between oxygen and carbon. Simultaneously, this bond is shifted toward this carbon atom, and this carbon atom become a negative species, and this negative species attach on SN2 type on this carbon atom. Okay, so here Cl will be removed, and we will get this type of final product like that. Look here, pi bond will be generated. Here one hydroxyl group is also present. Okay, this carbon is bonded with this 6 member cyclic ring. Okay, and here this phenyl group is attached, or simply I am representing this phenyl group like pH. Okay, here Cl will be removed, so we will get this type of final product. Okay, here we can use a reagent hydroxyl group, so we will get acid product. Okay, and here Cl will be removed. So this is the Quasi-Favorski reaction and their mechanism. Okay, the mechanism of the reaction is two step. In the first step, nucleophile reagent is attacked on carbonyl carbon atom of this alpha haloketone to form an intermediate product, and then the new intermediate product is rearranged to form a final product. Okay, I hope you will be understand the Quasi-Favorski reaction. This reaction is also called as benzoic acid reaction mechanism. Okay, simply it is called as Quasi-Favorski reaction, or it is also called as benzoic acid molecular rearrangement reaction. Okay, so sometimes in your exam this type of question is also asked for the confusion. Okay, this reaction does not show normal Favorski reaction because of here at alpha position of substrate molecule no acidic proton or no alpha proton is present. This is the main difference in between Favorski reaction and Quasi-Favorski reaction. Okay.